Okay, today we are moving on to a new lecture. Until last week, we have completed two lectures on memory management. So they are very important lectures in terms of we have the whole filling algorithms, first fit, best fit, worst fit, and after that we discussed about paging. And in the previous lecture, we talked about what is demand paging. Page replacement algorithm is one of the important topic, so practice it well. So last week we have seen the example of how to use the first in first out optimal page replacement algorithm and the the least recently used LRU. So three algorithms we have seen about the page replacement, and in the end, we have seen some theory that how to allocate the frames to the process. Now, today's lecture is little bit lighter, and actually in the past semesters, this lecture and the next lecture were actually one lecture, one chapter. Okay, so lecture 9 and lecture 10, actually in the original course previously it was just one chapter, but now they divided it into two chapters. This lecture is about the concept of files. So file system, and in the initial part of this lecture, we already know the concepts of files. It's easy lecture, little bit lighter to understand. As we have, I think we completed the heavy part of the course mostly. Okay, so what we are going to see today is working with the file. We know the concept of file. Today we'll try to revise about the files. What are all the different file access methods we have? First we'll understand about the file, then it will be easy to know what are all the file access methods. And we know that the data in the system is kept in the directories. In the Linux commands also, we practice the commands for creating the directory. If you remember, make directory was the command. We practice to create the folders. Then we will discuss about the file system. How do actually the file system works in different operating systems? In Windows, how it is, in Linux, how it is, we are going to understand. Disk allocation method. This we are not going to discuss in this part of the lecture. Next lecture, we are going to talk about this topic, which is disk allocation method. Students, am I audible? My voice is clear?
Yes, Mister.
Okay.
Mister,
Yes, please.
we want to repeat quiz now.
Okay, so let's continue that.
Yes, mister.
The
Is
concept
it
of
Very
file.
difficult.
Yes.
The concept of file. First of all, we need to understand that we are familiar with the files. So what basically we know as a user, we just refer as a file. Like I am now working with a PowerPoint file. We work with Microsoft Word file. We work with the Excel file. So we have various kind of files in the computer. We just call it as a file. What we know is we go to computer, we work on, for example, Microsoft Word, Excel, PowerPoint, or any file. We just try to save as a file. That's what we know. And when we save it as a file, what general concepts we apply? We give file name, and we know that where are we? Ajay, I'll make it simple. Where are we storing? Location of the file, whether it is a C drive or whether it is a D drive or whether you are storing in a F drive, which is our flash. So where are we storing the file? That's what we generally know about the file. That is something not real. I mean, it is not a real thing or a physical thing. We just want to save our work. What is generally a file? It is our work. We want to save in the computer. For that particular work, we give a concept of file, and each file contains the file name, and each file is going to be stored in a particular location. That's what we know about the file. But what happens in the background? That's what we are going to understand in this lecture. So operating system, what is the job of operating system when we are saving the file? So for example, when I open, now this is my PowerPoint file. I open a new PowerPoint. I created a presentation. Now I'm just and saving a file. So I just say I want to save the file, for example, in desktop, and I just give the name test file. That's what our job is. The file will be saved in the desktop. But how exactly the operating system is going to handle this work? We are just giving a job to the operating system that I want to save my file in the computer. But how operating system is going to handle about working with the files, we will see today. Okay, so what operating system? The operating system maps. What it is going to do, it's going to make a linking, maps the file onto the regions of the secondary storage. So once we want to save the file, if you just understand this concept, it will be clear. So we just give file name. Suppose ABC is my file. Once I just click save, what operating system is going to do, it will take the file information, the data of that particular file. We know with the name, that is ABC. But what operating system has to do, it has to take the whole data and it is going to store onto hard disk. It's going to store onto hard disk. Whenever we want to open the file, it's going to search the hard disk and it's going to bring the data back from the hard disk. That is the job of the operating system. The operating system maps the files onto regions of the secondary storage. We know the secondary storage is the hard disk. So when we are saving it, we just know the name of the file, whether we want to save it in a C drive or whether we want to save it in a D drive or wherever it is. It will just the file name is just a logical name. It will take the whole data and then put onto the hard disk. Now in the hard disk, there is no name called ABC. It's just our data. This is just our data in the hard disk. But the I'm just giving the whole idea of the lecture in this slide. The operating system know that there is a file called ABC and the data is stored on disk blocks. Disk blocks. So what do we mean by disk blocks? We know our hard disk. You remember next lecture also, not next lecture, the last lecture we'll talk about the hard disk again. Normally we know in the hard disk we have the platters. In each platter we have the sectors. The data is divided into sectors. Okay, so we normally call it as disk blocks. Disk blocks. So which means our hard disk is going to have blocks. So whenever we are saving the file, what the operating system remembers, there is a file called ABC and where this file is stored. I mean the disk block. Where is the starting block? Where is the ending block? Where is this file in the hard disk? Whenever we are just opening, so when we double click the file, what happens? Now the operating system should search and go to the hard disk, find out where is the file, collect all the information from here and then show the file to the user. So that is what is actually the file concept. The operating system provides a logical unit of the storage for the user. It is a logical unit, so not a physical thing. It is something logical, just has a name. And when we have when we are working with the computer, we refer each of our work with the files. The user refers to files. And when the user want to save the file, the operating system maps the files onto the regions of the secondary storage, means it will put the data onto the secondary storage. That is the whole concept of files. But how actually it happens, some background of the files and what are all the disk allocation method. That's what we have seen here, the disk allocation method. Is it going to give next location, or is it going to give different locations? How the disk will be given to the file. Disk allocation method means how the disk will be given to the file. That we are not going to discuss in today's lecture. We are going to discuss in next lecture number 10. Okay, but we are going to understand today how do we access the files, how do the directory will look like, that is the folder, and some background concepts of the file. Okay, so what does the file hold? It's a collection of data, related data, or maybe it's a sequence of lines in a program. Suppose if we take Java program, what will be there in the file in Java program? It's a file, contains lines, the codes. Okay, sequence of words in the text document. Like if I take a Microsoft Word file, what will be there? It will be just sequence of words of the text. Where are we going to store the file? We are going to store the file on secondary storage. Normally we know secondary storage may be hard disk, or maybe CD drive, or maybe DVD drive, or maybe the memory card or memory flash drive. We are going to store the data onto secondary storage. Okay, now when I talk about files, what is the structure of the file? Different files will have different structures. For example, if you take a text file, like we create the text file by using Notepad, it contains just lines. If you take a PowerPoint file, it contains a proper structure, how the presentation is designed. If you take, for example, Microsoft Word file, it contains pictures and lines. If you take a Java file, it contains just lines. What will be in Java? We have the program, and each line is separated by semicolon. So that is our Java file. Each file is different. Each file is having different structures. So what a user can do, we know the user can create the file, the user can write the data into the file, the user can read the data from the file, the user can search the file. Please remember, reposition means it's actually searching. The user can search for the file, the user can delete the file, and the user can truncate. Truncate means we know it is called as compression. Compression or compress with WinZip or WinRAR. So we compress the file. We either WinZip it or zip it, or we WinRAR the file. Means we are going to reduce the size of the file. These are all the operations we can do with the file. We can create, we can write, we can read, we can search, we can delete, we can compress the files, and all happens with the help of system calls. We have seen in lecture number 2 about system calls. Okay, so what is file? It is something abstract, means it is not real. As I told you, it is a logical name. It's an abstract data type. What file operations we have? Already I explained to you. We can create file, we can write, we can read, we can reposition, is like searching, we can delete, we can truncate. And one example here, open means it is going to open the file. Close means it is going to close the file. So in Java, you might have understood or discussed about the file commands in Java. We can open the file, search the directory structure on the disk for the file, which is F5, and move the content of the entry to the memory. So that's what I told you here. It will search the information from the hard disk, bring the data onto the memory. So that is opening of a file, closing of a file. Okay, so what are all the attributes of the file? So these are all the concepts generally we know. Each file has got the file name, and each file is associated with a type of the file. What do you mean by type of a file? Is it a PowerPoint file? Or is it a Excel file? Or is it a Word file? Or is it a HTML file? Or is it a Java file? So what type of file it is? Each file is associated with a type and location. Where are we saving the file, and the size of the file in MBs. Okay, so these are all the points we already know from our first year of IT. And every file has got the protection, whether we can read the file, read only, or whether we can read, write. Means we can read the file, also we can write the data into the file. Read-only file means we can only read the file. We cannot make any modification to the file, or even we cannot delete the file. And each file contains housekeeping information. So if you go to the draft, so we have the files. For example, if I take this is the housekeeping information. When we give right click and we say properties, so this is the information about the file. What is the name of the file? What is the type of the file? Where this file has been created? What is the size? What is the size on the hard disk? When it has been created? Whether it is read-only file or hidden file? What type of file? So all the information, we call it as housekeeping information. So when it is created, when it is modified, all the details. So each file we can see these are all the housekeeping information. When it is created, when it is modified, when it is accessed. We already know all these points because you are already in IT for many years. You know these concepts. So this is called as housekeeping information. The type of the file, it is a PowerPoint file. It opens with PowerPoint. Where is it? Size of it. This is housekeeping information. And attributes, whether it is read-only or whether it is a hidden file or what type of file it is. So that's what they mean by file attributes. So where is this information kept about the file? This information is kept in the directory, or in our terms, we call it as a folder. We call it as a folder. So this is how the information about the file is kept in the directory, or we call it as a folder. Just ignore this picture. It is something related to Linux. We have the kernel file table, but the Windows organization is different. So I will try to show you a different picture in the next lecture, because next lecture, lecture number 10, we talk about exclusively handling the storage and the files. So this is not clear also, not useful. So ignore this slide. This is how the file is organized in the Linux environment. About this node table, I will explain in the next lecture. Okay, now talking about some virtual memory concepts here. Okay, so suppose, for example, I open, if you remember, the last lecture was virtual memory. Now we are talking about a memory mapped file. What is memory mapped file is? So generally, suppose I open Word, and for us it is Microsoft Word. But for the computer, it is a process. For example, it is treating it as, it is process 1, for example. Okay, and for this process, it will give RAM. Now I am working with Microsoft Word file. So what happens when we are working with the memory? Now we have a RAM. Okay, so opening a memory map file causes region of the process virtual memory to be associated with the file. Now we discussed about virtual memory in the last class. That is nothing but having a memory for that particular process. We talked about what is virtual memory, how it is implemented in the previous lecture. Now imagine that this is a RAM and the process 1 is Microsoft Word. Now suppose I open the file from the hard disk. This file is now brought onto the RAM. That is our memory. Now what I am doing, the file information is here in my RAM. That is for process 1. Okay, so the reading and writing of the file are implemented as reads and writes onto this memory region. Means when the CPU wants to work with Microsoft Word or this file, it will go to the memory, which is RAM, read the data from the memory and write the data to the memory. Means there is no link to the hard disk now, because now it is a memory mapped file. The data has brought onto the RAM. Now, whenever we are reading the data, whenever we are writing the data, that is already in the RAM. It thinks like that. It is working on the memory region. So reads and writes to this memory region. So whenever we are reading, whenever we are writing to the file, they are implemented as reads and writes to the memory region. So which means the CPU is going to read the data, write the data or read the data from this memory mapped file. Okay, so this is my memory mapped file. Now, once I close the file, suppose I close my Microsoft Word file, this process should also be closed. So that time what happens, when we are closing the file causes the region of the memory to be written back to the disk. Means until now, what I am doing, for example, now I'm working with the PowerPoint. Now I'm writing some information here in the PowerPoint. Where this information is written, not to the hard disk. The information is written into the main memory. So now once I close the file, the data from the memory will be taken from here and go back to the hard disk, and it will try to write the data back to the hard disk. This is called actually the memory mapped files. Normally it happens with that. It happens like it will bring the data from the system hard disk to the main memory. We are actually now working on the main memory. Once we are closing the file, it will take the data from here and go back to the hard disk. Okay, what are all the different file types? I will not read this slide. We already know there are document files, Java files, exe files, the zip files, the PDF files. I just want you to check this later on. There are all different type of files in our computer. If I have a multimedia like MPG, MP3, AVI, WMV, they are all for the audio, video, movies. Okay, zip file, RAR file, we know it is for archiving or compressing the files. PostScript or PDF file, JPG file, we know for the JPG for the picture and PDF for the Adobe PDF reader. Okay, and we have the word processor, which is document file. If you have a text file, .txt. Okay, source code file like Java, C, C++, they are the files. So we all know about different types. Now tell me one answer. Whenever we are saving the file, suppose now I save this file is saved as abc.ppt. Why do we have this extension? Can someone tell me? Why do we have this extension?
Because when we open the file again, it will open in PowerPoint.
Okay, so for the operating system to recognize what file is this, the file is associated with the file extension. So the extension will help the operating system to recognize which file is this, because when we are double clicking, imagine suppose I have two files. One is a Word file and one is a document file. Both of them ABC and ABC. ABC and ABC. If we double click on that, the computer cannot recognize if we don't have the extension. But if it have the extension, it knows that this is a PowerPoint file. The program associated with this is PowerPoint. It will open that with a PowerPoint. If it is a document file, it will open with Microsoft Word. This concept we already know. We need not to spend much time. Easy for the operating system to recognize. So that is the advantages and disadvantages of knowing the file extensions and the file types. What is the purpose of all this? .exe is executable file. .obj is the object file. Java is a Java file. Why do we need to know all these extensions? Advantages: knowing the file type limits the choice of which application can process that file. So that's the reason why when we have .txt, it will open with Notepad. If we have .html, it will open with Internet Explorer or the Google Chrome as any browser, because it will understand that it is an internet file. So it limits the choice of which application or which program can process this file. Easy. It don't attempt inapplicable operation. For example, printing out a binary file. Binary file cannot be printed, so that's why it will not try any inapplicable operation. If it is a printing file like this one, for printing PS or PDF or JPG, it will print. If we have any other file, it cannot print it. So it will not try to do some inappropriate operation or inapplicable operation. Now that they are the advantages. What are the disadvantages of having the file type? It is difficult or hard to deal with new file formats. Every time whenever we have a new file, the computer should know which program is going to open. That's why sometimes If you try to open the file, it will say, I cannot recognize the program. So how to open this file? Sometimes, it will ask us that which file is this, how to open the file. It is difficult sometimes to deal with new file formats. Okay, so especially the encrypted file, which are the binary but not executable file. There are different type of files. Just ignore this point. Try to understand that difficult to deal with new file format. Suppose I have .ps on file format. The computer should know what is this PS. It's a PostScript. It should understand that which program will open this. So it has to know each and every file format. Suppose we have PDF, and in my computer, if there is no PDF, I am trying to open PDF. It will say, I don't know what is this file, which program to open the PDF. It will try to process it, but if it cannot understand, it will ask us to select the program or the application which can process the PDF file. Likewise, sometimes it is difficult to deal with the new file formats. So there are some advantages and disadvantages of knowing the file types. Okay. File structure, already we talked about. Some files are just simple files, just sequence of words or sequence of bytes. Simple files, like if I open a text file, what will be here? Very simple structure. We don't have any picture in this. We cannot put any table in this. It's a plain structure, just some words. That's it. Simple structure. Or even if you take a Java program, it's a simple structure. Sequence of lines, sequence of words, and this is without any proper way. But there are now simple record structure like what I showed you, Notepad. It contains sequence of lines. Sometimes some programs has fixed length of the line. Sometimes variable length, means the line can be bigger or the line can be smaller. And this is a simple structure of the file, like I gave the example of a Notepad. Okay, even I will consider Java as simple structure, because what is there in Java? Just programs. Simple structure. But if you talk about some new file formats, they are a little bit complex, like Microsoft Word. I just give the example here as Microsoft Word. The structure here is little bit complex because it's not straight, means not just lines. In between, we may have table. In between, we may have picture. In between, we can change the size of the font. In between, we can change the color of the font. So there are, so many complex things which we call it as a formatted document. Means it's not a simple structure, but it contains little bit of formatting. Okay, so relocatable load files are different kind of complex formats. Okay, so how do we handle different kind of file structures? They are decided by or controlled by operating system and the particular program. Microsoft Word knows how to handle the formatted document. If we have, for example, here the HTML file, then the internet browser will know how to handle that file. So depending upon, so can simulate the last two with the first method by inserting appropriate control characters. What do they mean by this? How can we handle these files? That is decided by the operating system and also decided by the program with which we are working. So just to understand the different type of file structure. Some of no structure at all, just sequence of words. This was actually the olden way, the machine language files or the programming files, the old ones. But now we have simple structure files like Notepad or any Java program. Okay, the complex structure, the new files. So every file is of different structure. Okay, now how do we access the file? There are two types of file access method. This is the one we are not using now, but we need to know. So here, this is called as a sequential access. How to access the file? Sequential access. What is sequential access? We are going to read the data of the file from the beginning to the end. We cannot go in the middle directly. So I just want to give one example. So if you remember, maybe some of you have used it or not, I don't know. So we have in the car, cassette player. You know, we have a cassette, a tape with 2 reels, you know, to play the song. Have you seen this, students? Cassette player.
Yes.
Okay, so when we have the cassette player, can we directly go to song number 3?
No.
Can we directly go to song number 3 and play the song?
No.
No, because it will not support direct access. What we need to do? We need to forward. We need to forward the cassette, or maybe we need to reverse the cassette. Means we have to completely roll, and then we go to song number 3. So this is a way of sequential access. What is sequential access? A file pointer identifies a record within the file. So for each file, there is a beginning of the file. So this is the file pointer, for example. So it can be moved incrementally forward in the read or write operation, or to the beginning in the rewinding operation. What do we mean by this? We can either go forward or either we can come backward. Directly, we cannot jump into a particular file. If I want to read the file, for example, if I want to read the record number n, I cannot directly go there. I have to start with the recording of the, I have to start with the pointer number 1. Then I have to sequentially move, like I told you about the cassette. We have to sequentially move. When we reach there, then we can read the data. So the example hardware metaphor is tape. So in the computer also, we have tape drive. We discussed this in the memory lecture number 7, tape drive. Tape drive for reading and writing the data. So this is one type of file access method. So we have the pointer in the beginning, and then we are going to read from the beginning to end, or we are going to come backwards. That is called as a sequential access. Means sequentially only we can either read or we can write the data from the file. This is one type of file access method. Another type of file access method is like we have a CD. Nowadays in our cars, we have CD player. We have a CD player. So in the CD player, can we play directly song number 3? In the CD player, can we directly play song number 3?
Yes.
So if you understand the CD player, so we have actually the files viewed as a numbered sequence of records. So the operations of reading and writing can be carried out on any record in any order. So no need for us to follow 1, 2, 3, 4, 5. Directly, suppose I am playing song number 1, I can select from my remote 1, 2, 3. It will directly start playing song number 3. Means it will automatically move to the record. So here we have the tracks. It will move to the track and automatically it will start playing from that particular thing. So this is actually a method of directly accessing the file. Sequential access, this is direct access. And here the hardware metaphor is disk. I gave you the example of CD. We know CD is a compact disk. Okay, now they are talking about here hard disk. Okay, so in the hard disk, directly we can go to a particular place and then we can read the data. So what is the file? The file is viewed as a numbered sequence of records. Here, the file is a pointer. The file pointer identifies record within the file. So here the pointer, then it can read according to the pointer. But here we can directly go to the record because we have the numbers. So we can go directly to the particular number and then we can directly read the data from there. Operations of reading and writing can be carried out on any record in any order. Okay. Now directory. So I always am repeating my words many times. Directory means we have to consider it as a folder. How the data is organized in the directory. So suppose we have so many files in our computer. How to organize them? I normally, use the example of a library. Okay, so imagine you go to the library, and there are no sections in the library. There are no sections in the library. Means IT books, business books, English books, or communication books, all kept together in one location of the library. Do you think it is easy to find the books?
No.
No, because we have to search the whole library. Suppose in the IT itself, we have programming books, we have internet books, we have mobile application books, we have networking books, we have database books. So searching for the book is going to take long time. In the same way, in the computer also, we are talking about how do we need to organize the data. So since the number of files in the systems can be large, means there are so many files, it makes sense to group them in various ways. So how can we do that? Okay, so the file system is divided into partitions. First of all, what we are going to do with the hard disk, we are going to divide the hard disk into partitions. This is one type of organization. Okay, if I give you the example of library, okay, so we have one section for IT books, one section for the communication books, one section for the language books, one section for the biotechnology books. Like we want to put the partitions. Okay, so the file system is first divided into partitions. A partition can be thought of as a virtual disk. What we know about partition, it is not a physical thing. Physical means physical hard disk. But what is a partition? We have the hard disk. Virtually, we are putting a barrier. It's not a, breaking the hard disk into two. What do you mean by partition? In my computer, I have C drive and D drive. So I don't have two hard disks. One hard disk can be divided into parts. It is not a physical partition. Actually, it is a virtual partition, virtual disk. And each partition contains the folders or the directory for the files that reside on. So if you look at this picture, each partition has the directory. So partition 2 has the directory. So if I take only one partition, so it has got the directory. So likewise, we are going to have the hard disk or the files are organized into partitions first, and then inside that we have the directory. So what is directory? Remember this. The directory is a table relating a file name to its attributes. We'll store all the files in the directories, or we call it as folders. Okay. Now, single level directory. Imagine that I told you the example of the library. One big library. Single. So all the files of all the users are kept in single directory. It's going to be very difficult. Okay, so simple method is we use a single table, means single directory. When we do that, all files are contained in the same directory. If you look at the example here, there are so many files, folders, directories, and there are so many files. And searching is going to be very difficult. What are the problems here? Length and uniqueness of the file names. So here in the single directory, suppose you are a user. User 1, I am saving the file abc.txt, for example. You are user 2. You also want to save the file abc.txt. Not possible, because one single directory, one single folder for all the users is not a good idea. So that is the length and uniqueness of the file names. Means very difficult to maintain the files, because we know two files cannot have same name in the single folder. It's not possible. Okay, file type can be different, but single name for same different users, not possible. So if there are multiple users, it's going to be problematic. And also searching is going to take long time, because I told you, if I have a big library and if you are keeping all the things together in one location, it's going to take a lot of time to search the large directories. These are all the problems of having the simple single table, single directory. What is the solution? For each user, we can give a directory. So one directory or one folder per user. So have a master directory. Now this is the master directory. which stores how many users are there, and for each user there will be a user directory that I can store my files here. And in this directory I can have my own files, like dividing the library into sections. And in this section again, suppose this is IT, here database, programming, web development, so different sections, and in that we have different books. Likewise, having multiple directories, have a master directory which is a table of user directories. Now this is our master directory. It is a table of how many users are there in the computer. Remember, I told you we are talking about now not a single computer, we are talking about server. Or if you are talking about your computer at home, maybe multi-user computer. Multi-user computer where many people are going to use the computer. Okay, so when the user process refers to a file, if I'm user number 1, if I'm working in the system, the operating system searches only the user's directory. Means if I'm user 1, it's not going to check all the other directories, it's going to check only my directories, because I am only the person who logged in. That's why when we open the computer, Windows computer, we have the username and password. Once I put the username and password, only my data, my files, my directories are shown to me. That's how the operating system manages multiple directories. Okay, now if you can see this, it's like a tree. We have the root, the main one, then we have subfolders, then we have subfolders, then we have subfolders. So like 3 folders, spell, bin, program. In bin there are some folders, in spell there are some folders. Like we did in the we did the practice of the Linux commands. We created one main folder, we created the computer folder, we created the IT folder. So likewise, we can create the folders and we can have the files inside the folder. This is like a tree structure. So why we call it as a tree? I think I told you in the past, tree is like, we have the root, and then everything is like branches. Now this will be having branches. Now it will be having branches. That's why it's like a root. The main one is the root, and then we have the subfolders. Okay, but we see the picture in opposite way. That is, this is the root, and then we have the branches. Okay, so this is the tree structure. If you have data structures, maybe you come across this in this semester. Are you doing data structures? Are you doing data structures in this semester?
Last semester.
Yes.
Last semester, you might have discussed the concept of trees, right? And graph.
Yes.
Yes.
Okay, so this is the same concept, like we have the tree structure of the folders. Okay, so with the help of these tree structure directories, it allows the user to create new directories in their own directory. So we can have the user, our directory, in that we can create our own directory. To refer to an arbitrary file in the tree structure, we now need to specify the path from the root. Remember, we did the command, Linux command, pwd. If you remember the Linux command, print working directory. It's going to show the folder path. Where are we? For example, I'm working in C drive, documents, and then we have a file called abc.txt. Now this is the path we normally know. So whenever we are working on a particular file in the tree structure, we need to specify the path, because if I want to reach here, suppose if I want to reach this folder, I need to say spell and then mail, and then for example copy or PRT, and then I go to this particular last or first, and then I can reach here. So we need to specify the full path to reach the folder. Okay, a path can be absolute or path can be relative. So absolute means we have to fix the path like this. Relative means whichever the folder I am working, that automatically becomes the path. No need to tell C drive, D drive or something. If I'm working in a particular folder, automatically that will be the path. Or if you want to go to a particular path like this, we have to specify the fixed path, or we call it as a absolute path. Okay, current directory is the working directory. That's why we have seen the command pwd, print working directory. It will print the folder in which you are working now. I have given you the example in the Linux commands of pwd. It will show the folder where are you working. That's the current directory is the working directory. So creating a new directory is done in the current directory. So in the current folder, we can create subfolders. Okay, so like this is the path. So this is the root, user 2, directory 1, directory 2, and the file. So this is how we need to specify the path. You already know all these concepts of the files. Okay, so acyclic graph. If you want to, now we are talking about, we talked about tree. Now we are talking about graph. So what is this graph basically? It's like sharing the files. Suppose if you look at this file, it's now shared between two folders. Okay, so have shared subdirectories and files. It's a acyclic graph. What do you mean by acyclic? It's not like a cycle. We have some open things here. We have some open things here. Only one particular file is shared or linked. So what is acyclic graph? It allows sharing of files and directories. Implementation of having two directories point to the same folder, file, or directory result in a graph structure. Now you can see it is like a graph. So like a graph, but this graph is not, like a cycle graph. We have some opening here, and also we have some opening here. It's not like a cycle that it's everything close. Okay, so because from here there is another thing, and from here there is another file. So this is like having two directories point to the same file directly. It results in a graph structure. Such a graph must be acyclic. What do you mean by acyclic? There should not be a cyclic. It should be acyclic. So it should have some open ends. Should not be like circular graph. So commonly implemented using links. So here we are going to establish the link. So if you want to share something, we need to establish the links. Okay, so a link is a pointer to an arbitrary file in the directory structure. So in the folder, a link is just a pointer. It will just point out that this is the file, like it is pointing out this is the file. In the directory or in the folder, it will just point the file, and both of the folders can share the file. Okay. Now 2-3 concepts to complete the lecture. Now we talked about the folder, we talked about the hard disk. Hard disk contains partitions, and partition contains folders for each user. When we open the computer or when we start the computer, all those things like the hard disk, the partitions and the folders and everything, the files, which is, for each user we have files. So all those things should be ready for me. When I open my computer, everything should be ready. So it has to go to the partition, it has to go to the folder of my name, and then all the files related to my user should be ready for me. So when I open with my username and password, the computer should show all the things related to my user. Now this whole process of making the system ready is called as mounting. The whole process of making the activation of the partitions, making the right choice of the user, and then making all the files ready for the user. This whole process is called as mounting. So what is mounting? To make file system available to process, it must be mounted. What do you mean by mounted? It has to make everything ready for the user. Okay, the operating system is given the name of the device to be mounted, whether it is a C drive or a D drive or a network drive, from where I need to get the data, and the directory from which the file system will be accessible. For example, I am user 1 or user 2 or user 3. By taking all the information, the file is mounted, the system will then be available as if they were the files in that particular directory. So if I go to my user, my files, my data, my information will be available for me. So that is how it will make the system ready with all the files. This whole process is called as mounting. So what is mounting? To make file system available to the process. That is called as mounting. So how it will be mounted? It will make everything ready for us. So please understand and remember what is mounting. Even the mounting comes for the database also, because I just want to give you some background knowledge. Database also, if you talk about database, like a database of Oracle, it must be ready in the computer. When you start with the database, working with the database, the database must be mounted. It should be ready in the system. So likewise, we have to make everything ready for the user. This process is called as mounting. Okay, so that's part of the lecture we have completed. One part is remaining of the lecture, that is how the file system is implemented in little bit of more details. What are all the different file systems we have and how is the disk given to the file. I'll just give one background and then I will stop the lecture. Suppose we have the hard disk, because it will make you think about the topic. So we have the hard disk and we want to save the file. In the disk allocation method, do we want to give continuous allocation, means all the data in one single place, or one block here, maybe one block there, maybe one block here, maybe one block there, maybe one block here, and make the links between the blocks. So there are different methods. There are different methods of allocating the disk to the file. One is continuous allocation. Second one is various methods I will tell you once we go into the lecture. We call it as indexed allocation. We call it as file allocation table. Each operating system has got different methods. So that we are going to discuss in our next lecture about the disk allocation methods. Okay, so hope you understand the points of today. That's about how to work with the file. So it's kind of a easy lecture where we just know about the concepts of the file. Only some background details we need to understand.